Valency. Just like elements have symbols, compounds too have a symbolic representation known as its formulae. Before writing the formulae, it is necessary to know how elements combine with each other to form compounds. For this, let us define a new concept called valency. Valency is the combining capacity of an element. To find out this combining capacity, you need to know how many electrons are there in the outermost orbit of an atom of an element. These are known as valence electrons. All elements after atomic number 3 tend to complete the octet of electrons in their outermost orbit, that is, a stable state when there are 8 electrons in their outermost orbit. They do by donating, accepting, or sharing electrons of the outermost orbit with electrons of other elements. In doing so, they form chemical bonds with the other elements, leading to formation of compounds. Valency. Examples. Students, see a few examples. 1. The electronic configuration of sodium is 2, 8, 1. It has 1 electron in its third orbit. Sodium tends to give up this electron so that it is left with a state 2, 8, which is stable. The loss of 1 electron leads to the formation of sodium ion, which is positively charged as it has lost 1 electron. Therefore, the valency of sodium is 1. The electronic configuration of chlorine is 2, 8, 7. It needs 1 electron in its third orbit to complete its octet and become stable. When sodium and chlorine atoms come together, sodium gives up 1 electron to chlorine. It takes up this electron and changes into chloride ion, 2, 8, 8. The valency of chlorine is 1. Sodium ions and chloride ions are bonded to each other by this transfer and form a compound sodium chloride or NaCl, which is the chemical name for common salt, an integral part of our food. 2. The electronic configuration of nitrogen is 2, 5. It needs 3 electrons to complete its octet. It completes its octet by sharing 1 electron each with 3 hydrogen atoms whose electronic configuration is 1 to form the compound ammonia or NH3, which is a strong-smelling gas. The valency of nitrogen is 3 and that of hydrogen is 1. 3. Hydrogen is an exception to the rule. It has only 1 valence electron. Hence, it shows a tendency to either give its electron or share it. Therefore, its valency is 1. 4. The elements having atoms with full electron shells, such as helium, neon, argon, are chemically inert. These atoms are stable because they do not tend to give, accept, or share electrons, ions, and radicals. Sometimes groups of atoms also give up or accept electrons, forming positive or negative groups. Such atoms or groups of atoms having a positive or negative charge are known as radicals. Sometimes positive or negative sign is written before their valency to indicate whether they donate or accept electrons. The number of electrons which any atom donates or accepts is also indicated through symbols. For example, sodium ion is written as Na plus and chloride as Cl minus. Magnesium ion is written as Mg2 plus, indicating that the valency of Mg is +2 and that it tends to donate 2 electrons while forming a compound. Students, here is a list of some commonly used ions and radicals. Knowledge of ions and radicals is useful in writing molecular formula of a compound as well as to understand and to write balanced chemical equations. The monoatomic single positively charged ions are hydrogen, sodium, potassium, silver, and copper 1. The monoatomic negatively charged ions are fluoride, chloride, bromide, and iodide. The polyatomic single positively charged ion is ammonium. The polyatomic single negatively charged ions are hydroxide, bicarbonate, nitrate, and nitrite. The monoatomic double positively charged ions are magnesium, calcium, iron 2, and copper 2. The monoatomic double negatively charged ions are oxide and sulfide. The polyatomic double negatively charged ions are carbonate, sulfate, and sulfite. The monoatomic triple positively charged ions are aluminium, iron 3. The monoatomic triple negatively charged ion is nitride. The polyatomic triple negatively charged ion is phosphate. Some elements show variable valency. The alternate valency shown by elements is indicated in brackets by the side of their ions in Roman figures. Chemical formulae of compounds. Students, now let us use the table of ions and radicals to write formulae of some common compounds. To write the formulae of potassium chloride, first write the symbols of potassium and chlorine. Then write the valencies below the symbols. Cross-multiply the valencies to get the formula of potassium chloride as KCl. To write the formula of water, first write the symbols of hydrogen and oxygen. Then write the valencies below the symbols. Cross-multiply the valencies to get the formula of water as H2O. To write the formula of sodium sulfate, first write the symbols of sodium and sulfate. Then write the valencies below the symbols. Cross-multiply the valencies to get the formula of sodium sulfate as Na2SO4. Students, in these examples, you would have noticed that the charge on the ions have been balanced.